In this chapter, we move to automation in smart, connected ecosystems and the impact of AI empathy on customer well-being. Automation is often presented as a promise of efficiency, speed, and optimization. In smart ecosystems, automation connects data, devices, platforms, and artificial intelligence into seamless systems that increasingly act on our behalf. However, the central question is not whether automation is possible. It is whether automation truly creates value for users. The core question is simple. Does more technology automatically create more value when technology strengthens trust, empowerment, and human relationships? We argue that more automation does not automatically lead to better experiences, higher adoption, or stronger relationships. Automation can empower users, but it can also distance them psychologically, reduce perceived control, and increase feelings of risk. In smart connected ecosystems, value emerges when automation supports human decision-making rather than replacing it. The challenge is to design automation that enhances trust, preserves user control, and improves well-being. This chapter therefore examines automation not only from a technological perspective, but from a psychological and experiential one. We explore how different levels of automation influence trust, emotional engagement, adoption, and user well-being. We show that moderate, human-centered automation often creates more value than full autonomy. We also demonstrate how emotional responses, stress, and technology-related fear can be measured and used to guide responsible automation design. Ultimately, this chapter positions automation as a strategic design choice. Automation should not aim to maximize autonomy. It should aim to maximize meaningful, trustworthy, and well-being enhancing human-AI collaboration. Our approach to the result is research supported by high scientific legitimacy. The work is multi-method in simulated lab experiments for smart homes and autonomous self-driving vehicles in Germany. We conducted a large-scale study with 1 to 200 respondents on self-driving cars. This study explored the shift from being a driver to being a passenger in an AI-driven vehicle environment. In our research, we compare how different automation levels, partial automation, level 2 or 3, or full automation, level 5, influence adoption factors. The question, how much control does the car take away from the human, and how does this impact psychological and physiological mechanisms? This is our semi-autonomous self-driving vehicle in Stuttgart, Germany, where users experience semi-autonomous driving. This is our virtual reality autonomous self-driving vehicle in Stuttgart, Germany, where users experienced fully autonomous level 5 driving. This is our test campus shuttle to experience public transport in semi-autonomous environments. We measured user experience not only through surveys, but also through neurophysiological indicators like EEG, eye tracking, and galvanic skin responses. This matters because adoption is not only a tech question, it is also psychological, physiological, and contextual, so we need strong methods and multiple contexts to get reliable insights. Let's move to the results of our research on smart mobility. More automation does not automatically create more value. This confirms our findings about user empowerment. Automation, yes, but by keeping control of the process. Let us look at the detailed results. At moderate levels of semi-automation, typically levels 2 to 3, users remain actively involved. They keep their hands on the task, they feel in control. Users experience assistance without surrendering control. In line with construal level theory, psychological distance decreases because the technology still feels like a supportive partner. Effort expectancy or perceived ease of use of the technology improves because tasks become easier due to AI assistance. Perceived technical driving performance improves because AI supports decisions, reduces cognitive overload, and makes driving more efficient by avoiding traffic jams and organizing trips. Psychological risk is perceived as lower because users keep control and can intervene at any moment. Most importantly, trust, perceived technology security, and well-being increase because users feel safe and competent and less overwhelmed by basic driving or cognitive tasks. On the other hand, in line with privacy calculus, privacy concerns increase because of a large amount of data collection such as driving habits or geolocation. But personalization benefits outbalance them. Behavioral intention to use the autonomous technology increases because the system feels still like a partner, predictable and controllable. As a result, semi-autonomous vehicle or technology adoption rises. In contrast, at very high automation such as level 5, the pattern changes dramatically when the control is fully transferred to the AI system. Users are no longer actors. They become passive observers. In line with construal level theory, psychological distance increases because the technology feels opaque, does not feel like a supportive partner, but as a substitutive power, making one lose the control. Therefore, users feel afraid and controlled and overwhelmed by delegating the steering wheel and driving tasks to the AI. Despite increased technical driving performance and perceived ease of use, perceived control drops sharply. This loss of control reduces trust, perceived technology security and well-being. Furthermore, privacy concerns increase because of the increasing amount of data collection that the AI needs to control the car. The automation and personalization benefits cannot outbalance the technology and privacy fears. Emotional engagement drops, well-being declines. As a result of this psychological process, behavioral intention to use these fully autonomous technologies decreases dramatically because the system feels freaky, frightening as non-predictable and non-controllable and not like a partner. We now turn to neurophysiological evidence that supports these findings. EEG measurements allow us to observe emotional reactions that users may not explicitly report, in contrast to our surveys. We can see that as users gain experience with automated systems, the frontal alpha asymmetry that measures emotional valence increases. Higher values indicate a more positive emotional state. This means that stress decreases and positive emotions like well-being emerge. In other words, experience with automation reduces technology fear and increases well-being. The human brain adapts. The system feels more and more familiar rather than threatening. This effect is weaker under full automation, where loss of control persists despite experience. But still, we can conclude that UX with automated systems decreases stress and increases well-being and subsequently adoption. These results are confirmed by our galvanic skin response test, providing complementary evidence. GSR measures physiological arousal and stress through skin conductance. Higher peaks indicate higher stress. As users interact repeatedly with automated systems, the number of GSR peaks decreases. This indicates user experience progressively reduces technology fear, stress, and increases emotional comfort, thus well-being. In contrast, full automation does not generate the same reduction in stress. Even with experience, physiological arousal remains higher because users cannot intervene. This confirms that psychological safety depends more on perceived control than on technical perfection. Together, EEG and GSR results show that user experience acts as an emotional learning process that reduces stress and increases well-being. With partial automation, users build trust over time. Fear decreases, comfort increases, positive emotions emerge. With full automation, this emotional learning is disrupted. Loss of control prevents full emotional acceptance. This explains why well-being is a central mediator between automation and adoption. We can thus conclude that UX with less or more automated systems reduces stress, as we can see with the EEG and GSR, increases well-being and subsequently adoption. This confirms that trust, well-being, and familiarity are key drivers of adoption. To summarize our theoretical findings, first of all, we find an automation paradox. This means that autonomous technology adoption does not increase linearly with automation because psychological factors outweigh purely functional benefits. As automation increases, the fear of losing control becomes more influential than performance gains. Regulatory focus theory explains these adoption patterns. Promotion-focused users are attracted by effective gains such as relaxation, comfort, and enhanced well-being when technology performs tasks on their behalf. Prevention-focused users prioritize safety, reliability, privacy, and control. At moderate levels of automation, users primarily follow a utilitarian prevention-focused path. Semi-autonomous systems deliver clear functional benefits while preserving control, thereby satisfying prevention-focused concerns. Trust and well-being increase, which drives adoption. At very high levels of automation, psychological dynamics shift. Loss of control activates prevention-focused concerns related to safety, dependency, and risk. Fully autonomous systems fail to satisfy these concerns and simultaneously weaken effective promotion-focused benefits. As a result, trust and well-being decline and adoption drops. When automation exceeds psychological comfort, negative emotions reduce well-being and override both functional and effective value. Here are our managerial key takeaways. Our research reveals a clear automation paradox that directly informs CRM and personalization strategies. While automation improves technical performance, it does not automatically increase trust, perceived value, or adoption. At full automation, users experience a loss of control, which reduces trust, well-being, and acceptance. Perceived value peaks at moderate levels of automation, where users remain empowered. For CRM, this means that automation should support relationships, not replace them. Automation is most effective when it assists users and enhances personalization while preserving perceived control. From a personalization perspective, this implies that depth and autonomy must be carefully calibrated. Highly automated personalization can feel intrusive or manipulative if users are excluded from the decision process. Transparency, explainability, and override options are therefore essential CRM design features. Neurophysiological evidence reinforces this insight. EEG and GSR measures show that lower stress and higher emotional comfort, not efficiency alone, drive sustainable adoption. Traditional CRM metrics underestimate these emotional responses. Successful marketing and CRM strategies must therefore balance promotion-focused and prevention-focused needs. Effective CRM automation must therefore optimize psychological safety and well-being, not only operational efficiency. Trust and emotional comfort are prerequisites for long-term relationship value. AI should be designed as a collaborative partner that augments human capabilities rather than replaces them. The solution is not less AI, but better designed AI. Smart CRM systems should foster human-AI collaboration, keep the customer psychologically in the loop, and use personalization to augment user autonomy rather than diminish it. Now let us map the automation paradox to the managerial action matrix. The automation paradox provides a clear organizing logic for the managerial action matrix. Across all data contexts, value does not increase with maximum automation, but with optimal automation aligned with psychological comfort and perceived control. In high-sensitivity domains such as health, finance, or mobility, the matrix prioritizes sovereignty and safeguards. Here, full automation is particularly risky. Level 5 automation amplifies fear of loss of control and reduces trust. CRM systems in these contexts should therefore rely on moderate automation, strong transparency, and explicit user override. The primary KPI is perceived security because trust is a prerequisite for both personalization value and adoption. In moderate sensitivity domains, such as energy management or location-based services, contextual transparency becomes the strategic focus. Automation should support decision-making without removing user agency. Semi-automated personalization increases utility accuracy while maintaining emotional comfort. Here, the matrix translates the automation paradox into a recommendation for adaptive, explainable automation rather than autonomous decision-making. In low-sensitivity domains, such as media, entertainment, or content recommendation, automation can be more proactive. However, even in these contexts, full automation should enhance delight rather than replace choice. Discovery and serendipity work best when users feel involved. Automation that removes agency reduces emotional engagement and personalization value. Across all cells of the managerial action matrix, empowerment functions as the regulating valve. It determines how much automation and personalization users are willing to accept. When empowerment is high, trust and well-being increase, enabling deeper personalization. When empowerment is low, even technically superior automation reduces value. The managerial implication is clear. Smart CRM does not maximize automation. It calibrates automation and personalization depth to data sensitivity, psychological comfort, and the desired relationship outcome. This alignment transforms automation from a technological feature into a relationship-building mechanism. Thank you for your attention.